vertically under gravity. So it's and this is our building. We just lodge it from here and it starts moving downwards. Okay, which graph best represents the variation of its height above the ground with time t if air resistance is negligible? Okay, I'm just drawing a small part over here to represent the brick. This brick, when moved forward over here and it is left to fall freely, it will fall under gravity. So acceleration of this brick will become equal to g, which is acceleration of free fall, right? Initially, its height from above the ground was h. This is actually the height above the ground. As time passes, this height will start decreasing because the brick starts moving downwards and downwards and downwards. It keeps on coming downward. So the value of this h must decrease. So C and D cannot be the answers because over here the values of h are increasing because h represents the height above the ground, represents the variation of the height above the ground. Okay, now let's look at A and B. Either A or B can be the answers. We know that this is an accelerated motion, right? Acceleration is equal to acceleration of free fall. So accelerated motion means acceleration is basically the rate of change of velocity or rate of change of velocity, right? So since we know that acceleration is the rate of change of velocity, this means that the velocity cannot be constant. Velocity cannot be constant because velocity has to change due to this acceleration, due to this gravity. And in the displacement time graphs, the gradient represents the velocity. In the B graph, in the option B, the gradient is constant, which cannot be the answer because the velocity has to change due to acceleration of acceleration due to gravity. Therefore, the only answer that we are left with is A. Now let's look at this graph. The graph of velocity time graph for an object moving in a straight line is shown. Okay, this is a velocity time graph. As we've seen earlier, that the velocity is actually the gradient of a displacement time graph. So consider this to be the gradient of all these graphs. It says that what is the corresponding graph of the displacement time graph? Displacement against time. Okay, so we just need to look at this and sketch a graph or just pick up a graph from the 4 options that we are given. Okay, initially, if we look carefully, the velocity is continuously rising and rising and rising. From here to the first mark, the velocity is continuously increasing. So this means that the gradient is continuously increasing. In the 4 options, in option B, the gradient is 0. So B cannot be the answer. In option B, the gradient is 0, so B cannot be the answer. Let's look at option D. The gradient is constant. It's not 0, but it is still constant because the gradient is not, the slope is constant. So D cannot be the answer either. Let's look at A and C. Okay, so the initial parts, in both the initial parts, the gradient is increasing. Okay, then the gradient becomes constant. It reaches a maximum value, Vmax. Let's call it Vmax. At this point, the gradient becomes constant. So in both the graphs, the gradient is almost constant. Over here as well, the gradient is constant, and here as well, the gradient is constant. This is the part that will decide which graph is correct. Okay, over here, the velocity starts decreasing to 0. But velocity is decreasing in the positive axis. It is not going below 0. It's not going into the negative axis. In the graph A, the gradient has become negative. So A can also not be the answer. It's C. C is our answer. Okay. Now the last question. The mass on the end of a spring bounces up and down as shown. Okay, this is the distance time graph of a mass that's moving up and down on a spring. Which graph shows how the velocity varies with time? Okay, so we know that the velocity is basically nothing but the gradient. Velocity is the gradient of displacement time graphs. So let's look at the gradient and figure out which graph is correct. If we draw a tangent to this graph at its point 0, the tangent is going to be a horizontal line. This is our tangent, a horizontal line. Okay, a horizontal line always has its gradient 0. Okay, so basically this means that initially the velocity has to be 0. So it can either be A or it can be C or D. A, C, D. B cannot be the answer. Okay, so B is ruled out. Then if we look at the graph, the tangents, and if we start drawing more tangents, the gradient of the tangents, it starts increasing. The gradient of the tangent starts increasing. The gradients of the tangent starts increasing, and at this point over here, the gradient becomes maximum. Gradient initially was 0, then as time passes the gradient starts increasing and it becomes maximum over here. So the gradient has to increase and become maximum. It has to increase and become maximum. It's in this case the gradient is increasing and becoming maximum too actually. Okay. So now let's go forward. The gradient is decreasing and becoming 0 again. If we look at these points carefully at this point and compare them to each of these graphs, so at this point, and this point, over here the gradient must be maximum. It must have a maximum value. In point C, the value of the gradient is 0, so C cannot be the answer. Okay, so 2 ruled out, 2 left. Then as the time increases, the gradient starts decreasing and becomes 0 again. Okay, in both the graphs it's 0. Then till here both the graphs are going the same. Okay, A and D, till the half of the cycle they are going the same. But after the half cycle is finished, the gradient becomes negative. In this case, gradient now becomes negative and starts increasing in the negative. It starts increasing in negative. Only in graph A the gradient has gone, the velocity has gone below 0 and becomes negative. So A is our final answer.